Hello and welcome. Let's take a look at how to find the inverse of a 3 by 3 matrix. Alright, so we're just going to do one good example here. Example 1, and then I'll let you try example 2. See how you go with this. So there's only one real way to do this that I know of, and this is to use the Gauss-Jordan elimination method. So let's set up our augmented matrix like usual. And there we go. Remember what an augmented matrix is. It's the matrix A that you're finding the inverse of, and it's split and shared with this matrix box with the identity matrix. Okay, so this is our matrix A here, over here, and this is the identity matrix here. Okay, our 3 by 3 with our main diagonal full of 1s and all the other numbers are zeros. So let's proceed with the Gaussian elimination process. First thing is we need a 1 up here. So we're going to add the first column to the second column. I think that's the easiest way here. So my advice is write the rows that are not going to change first. Okay, so we're just going to copy down rows 2 and 3. Row 1 is the one that's going to change, and we're going to do row 1 plus row 2 in the previous line. So let's do it. 2 plus -1 is 1. There's our leading one as we wanted. -17 plus 11, -6. 11 plus -7 is 4. 1 plus 0, 0 plus 1, 0 plus 0. There we go. So now we have our leading one. We're going to use that one to turn everything below that into 0. Okay, so the first row is not going to change and the third row is not going to change. Let's write them first. So how do I use this 1 to turn this into a 0? I'm just going to add row 1 and row 2. Again, weird, huh? Here we go. 1 plus -1 is 0. -6 plus 11 is 5. 4 plus -7 is -3. 1 plus 0. 1 plus 1. 0 plus 0. Okay, so we now have our 1, 0, 0. We now need a leading one here in the second row. But we want to avoid fractions, so how can I use multiples of 5 and 3 to end up with a 1? I know. Let's double the third row and subtract the second row. So the first row and third row are not going to change. Let's write them first. Alright, so let's do this. We're going to double this and subtract this. So 2r3 minus r2. This way we'll avoid fractions. Double this, subtract this. Double this, 6, subtract this, 1. Double this, -4. -4 minus -3, be careful here. -4 minus -3 is -4 plus 3. -1. That's tricky. Double this and then subtract this, -1. Double this, subtract this, -2. Double this, 2, subtract this, 0, which is still 2. And we'll just bring that up there. So now we've got our second leading one, and we want to turn this into a 0 as well. Let's copy this down again, and the first 2 rows are not going to change. Let's do that. And done. So how am I going to use this 1 to turn this 3 into a 0? I'm going to multiply the second row by -3. And then add that to the third row. Okay, so -3 times that is 0, plus that is still 0. -3 times that is -3, plus 3 is 0, what we wanted. -3 times -1 is 3. 3 plus -2 is 1. Oh, look at that, and we get our other leading one there. -3 times -1 is 3. 3 plus 0 is 3. -3 times -2 is 6. 6 plus 0 is 6. -3 times 2 is -6, plus 1 is -5. Well, we got lucky with that one, didn't we? Okay, so now let's use this leading one to turn these into zeros. Let's write the third row first, because that's not going to change. Like so. So how can I use this 1 to turn that into a 0? Well, we're just going to add the 2 rows together. Row 3 plus row 2. 0 plus 0, 0. 0 plus 1, 1. 1 plus -1, 0, what we wanted. 3 plus -1 is 2. 6 plus -2 is 4. -5 plus 2 is -3. And how am I going to use this 1 to turn this into a 0? Multiply this by -4 and add it to the first row. So -4 times that is 0, plus 1 is 1. -4 times that is 0, plus -6 is -6. -4 times that is -4, plus that is 0, what we wanted. -4 times that is -12, plus 1 is -11. -4 times that's -24, plus 1 minus 23. And negative 4 times negative 5 is 20, plus 0 is still 20. Okay, and one more step. We just got to use this 1 now to turn this into a 0. And we have our identity matrix on the left, and we're going to have our inverse matrix over here. So only the first row is going to change. There's the second and third row already done. So how am I going to use this one to turn that into a 0? I'm going to multiply the second row by 6 and add that to the first row. So 6 times 0 is 0, plus 1 is 1. 6 times that is 6, plus negative 6 is 0, which is what we wanted. 6 times that plus that is all 0 still. 6 times 2 is 12, plus negative 11 leaves 1. 6 times 4 is 24, plus negative 23 is 1. Oh, numbers are getting small again. 6 times negative 3 is negative 18, plus 20 is 2. Now the Gauss-Jordan process is over, and this is our result. What you see here is now the identity matrix on the left, and on the right is our inverse matrix, okay? So here's our original matrix, this is the inverse matrix. But for your answer, don't leave it like that. Write the inverse matrix separate over there somewhere. Like so, okay? This is your official answer, okay? The inverse matrix, 3 by 3 matrix like the original. So is that the right answer? Do you trust me? Yes, but the 5 should be negative. He copied it over wrong. Don't worry, he realizes it in a second and fixes it. He's a bit slow. Well, if you don't, how can we check it? Remember, what is the definition of an inverse matrix? It's the matrix such that the original matrix times this inverse matrix, this times this should give the identity matrix. Again, in this case, the identity matrix would be I3, wouldn't it? So why don't we just do it, see if it works. There we go, all set up. Okay, so the original matrix times the inverse matrix, will that equal the identity matrix? Let's give it a shot. So finding this first entry here, okay, the first row and the first column. 2 times 1 is 2. Negative 17 times 2 is negative 34. 11 times 3 is 33. So what was that? 2 minus 34 is minus 32, plus 33 is 1. Okay, the second element here. So this row and second column, 2 times 1 is 2. Negative 17 times 4 is negative 68. So 2 minus 68 is negative 66. 11 times 6 is plus 66. That leaves 0. Oh, mistake there, I forgot to put the minus 5. So the final entry here, top row and back column here. 2 times 2 is 4. Negative 17 times negative 3 is positive 51. 4 plus 51 is 55. 11 times negative 5 is negative 55. That gives 0. Okay, the next one. This one here. This row and the front column here. Negative 1 times 1 is minus 1. Plus 22 is 21. 21 minus 21 is 0. Next one here. Okay, middle row, middle column. Negative 1 times 1, minus 1. Plus 44 is 43. And negative 7 times 6 is 42. Plus 43 minus 42 gives 1. Final entry here. Okay, middle row, back column. Negative 1 times 2, so that's minus 2. Minus 33 is minus 35. Negative 7 times negative 5 is plus 35, giving 0. And the bottom row here, let's do the first entry, okay? Bottom row and front column. This times this is 0. 6 minus 6. Okay, 6 plus minus 6 is 0. Second one, okay, bottom row, middle column. 0 times 1 is 0. 3 fours are 12. Minus 12 is 0. And the last one here, okay, bottom row, back column. 0 times 2 is 0. 3 times negative 3 is negative 9 plus 10. Negative 9 plus 10 is 1. And there we go, indeed that does work. That is the identity matrix, I3. Little thing for you to try. Is it also true if you multiply in the reverse order, the inverse matrix times the original matrix? Will that also give the identity matrix? Why don't you give that a try at home? Okay, see if it works. I think it does. How did you go? Were you able to follow that? I hope so, because it's now your turn. Please try example 2. Same deal. Can you find the inverse matrix of this matrix B here? Okay, you've got to use your Gauss-Jordan process again. Once you've got it, test it. Does the matrix B times the inverse that you found equal the identity matrix? And if you reverse the order, does it still work? Put your value for the inverse matrix in the comments section. Thanks for watching everyone, and we'll see you again soon.